of indicators are used for evaluating the people ahead. Means a number of vehicles are developed for road purpose to save the road accidents. In these technologies, the fusion of data that is recorded, purposely collected, opportunistically, and generated through crowdsourcing are used to generate new technologies about transport activity and its flow. It means that these technologies that are used in these autonomous vehicles are used knowledge base, means they are also already trained for the purpose. All information about the road, about the crowd points are already knowledge are trained to the vehicles. In these technologies, the location and trajectory data was inherently personal in nature, but it was difficult to anonymize effectively, although this data creates unique privacy risk and new avenues for misuse, such as potential manipulation of individual and their behavior and trajectories. Let's discuss what is the function of cloud and massive data in these vehicles. The exploitation of massive data was increasingly important and upsetting. First one, physical data regarding the effort use of municipal space by the citizens. Second one, real-time data regarding vehicles operations and condition of the road. It means there is no use, there is no purpose for developing autonomous vehicles. If we not train about the accurate information, it means it's difficult for autonomous vehicle to analyze the data. It means there is a chance of road accidents. Let's discuss self-enabling vehicular agent. A cloud and massive database self-enabling vehicular agent is used to improve the reliability and security to reduce the vehicular operational cost. Means a driver, a conductor, all costs are minimized by developing self-enabling vehicular agent. It's also used to develop, validate, and verify mixed integrity application with real-time requirements. When we develop any system, any vehicle, it means we always analyze it on the real-time data, not the previous data, not the future prediction. We always using the real-time data. Autonomous vehicles are needed to know what's next on the road, that is, road is free or not. Is there any construction or not? The basic purpose for developing a self-enabling vehicular agent, it should be capable to analyze the massive data on the road, means congestion of the road, and also to know is there any construction or not. The cloud and massive data enables the agent to avoid accidents, to minimize the road traffic, keep connected with the world around it, but not all the data is relevant to the agent. Basically, as this developed agent is only for road to avoid the road accident and to minimize the road traffic, not used for the whole world connecting, basically. Privacy of massive data in the vehicular agent. In vehicular agent, sensors are used to enhance road safety. Basically, how an autonomous vehicle can analyze the congestion of the road or road construction is used a sensor like a human. When we discuss the autonomous system, it means the system not a human but working like a human. It means when we discuss this vehicle, it means there are some sensors like a human to analyze the real-time data. In case of location data, data protection policies are lagging behind new modes of data collection and the usage, because we can 100% protect any kind of data, because these are the systems. These are developed by the human. In this agent, a privacy design approach is used that enables the user to control and allocate rights to their data, because failing to ensure strong privacy protection may result in the regulatory blackish against the collection and processing of location data. If we fail to analyze or to protect real-time data, it will be uh, any person or change the data by any person, it will create number of problems. Fully self-enabled vehicular agent can be likely confined to areas where the vehicle can confidently handle the full range of the driving complexity. We can't learn the data to autonomous vehicle of whole city. We only training the data specific road, specific area, not whole country, whole city, and the whole world. Here, I have developed a autonomous system. First side is the memory, means the number of memories are used in this autonomous vehicle, means sensory memory that is used to sense the real-time data. Working memory, that is the relation between the sensory memory and the short-term memory. Short-term memory, as you know, it's stored data for a short time, means 5 to 15 or 10 seconds. And the next is secondary memory or long-term memory that is used to store the data for a long time. It's also based on the episodic memory or semantic memory, where the function of episodic memory is to store the data each and every activity. Semantic memory is used for relating the data. And subparts are self-integrating, self-configuring. These are used for autonomous purpose. Self-integrating, self-configuring information analyzers, and learning configure. When we discuss autonomous vehicle, it means it should be capable to learn real-time information. When we change the location, when we change the area, it should be enabled to adopt the new location, new area for analyzing purpose. Self-healing means autonomous automatically adopt the new era, new information for autonomous purpose. Self-driving, it means there is no driver in these vehicles. These vehicles are autonomous. They move automatically. They move sense automatically. Road congestion, road construction, and everything around the road. Road cloud integration interface that is used a cloud data. There is no specific data. Data is received through sensors. That is used by using the cloud integration phase. And the massive data, it means it's stored every data in its database, means data, massive data, use data to analyze later on. That is the function of this autonomous system. Cloud-based systems are based on the number of parameters, that means self-enabling, I have discussed, self-scheduling, a number of other parameters I have discussed. Due to the short time, I can't explain every component here, I discuss only. Here I have discussed comparison between the personal vehicles that we use nowadays, driverless vehicles, and self-enabling agents. Personal vehicles, driver vehicles, and self-enabling per mile cost. Here we compare the cost per mile between the three types of vehicles. I had discussed miles, 5 miles, 10 miles, 5 to 80 miles. I had discussed. Here I discussed personal vehicles cost $0.2 for 15,000 miles a year. Here is cost 0.22. Here is cost 0.0555 kilometers. These are the 10 kilometers. These are 5 kilometers. Here we compare up to 15 kilometers. Its cost is $0.08, but its cost is 0.22 or 0.2, $0.2. As compare later, here the cost is 0.41, 0.31, and 0.51. These are the comparison of the cost per kilometer between these vehicles. Thanks. Is there any question from audience? Hello. Hello. Is there any question from audience?
Thank you so much, sir, for sharing the light on a very actually interesting topic, that is autonomous vehicle. Thank you so much, sir.
Thank you. Allah.
Um, that was Dr. Shailen Singh, and he delivered his presentation on the autonomous vehicle. That is actually one of the most current and challenging topics right now. Okay, so let's call our next speaker. So today, actually, we have a very special guest with us. So we have Professor Dr. Said Asad Raza Kazmi, Chairperson, GCU. So I think you don't need an introduction, but I will definitely introduce him. So he's actually professor and chairperson of Department of Computer Science at GCU. He completed his PhD in computer sciences from Key State Laboratory of Computer Science Institute of Software Chinese Academy of Sciences, Beijing, China. He joined GCU as an assistant professor in computer science department in 2008. And since 2019, he gained his position as professor and is working as a chairperson of Department of Computer Sciences. He has supervised many prestige MS and PhD theses. Moreover, his profile consists of many impact factor and index research publications at well-reputed journals and conferences. So, ladies and gentlemen, please welcome Dr. Professor Dr. Said Asad Raza Khan.
इसमें फाइल है प्रोसेस अलजेब्रा की फोल्डर है फोल्डर सॉरी ऊपर
focus.
Okay, I can start now. Can you start now?
Yes, sir.
Thank you very much. Thank you. Uh, I'm thankful to the university and for inviting me. And I would like, my area is basically formal method, and it is an area where we going to have the modeling of safety critical systems in mathematical way and making use of temporal logic and model checking techniques. We can apply those techniques in order to get any kind of error in a system. So where high precision is needed, where high accuracy is needed, this kind of area is basically needed. So its application is really in safety critical systems. Like the safety critical systems are those systems in which if there is a failure, then there is a risk of life or human life or a very huge kind of loss of money. That's why it's not meant for ordinary software, rather very specialized software verification and modeling. So it's just a kind of introductory kind of talk because the perplexity of mathematical nature of this area is something complex. So that's why the talk is about this. I'm sorry, your keyboard is not working. I think so. अगर आप मेरा लैपटॉप लगा देते तो सच चीजें it's not working. This one. Okay, this one. Okay, thank you very much. So model checking and process algebra. I have a limited time. I'll try to finish it up in. Thank you very much. Okay, and so if you look at the concern about testing and modeling, and if you look at this picture, then we can have the testing. It can extract few bugs out of the system, but when you make use of model checking, you could have you can identify many bugs in that. That's why this pictorial representation gives you an idea that this model checking kind of technique is much better as compared to the testing. And secondly, the testing is being done primarily on a system already developed, while model checking is being done on the system where we have a mathematical model of the system, functionality of the system, then we apply this technique on that, and in order to get any kind of malfunctioning so that the system could work properly. So that is the concern. And you can see that the only a limited number of test cases can be analyzed for simulation and testing, while the model checking possible behavior of system modeling revealing hidden errors. So in model checking, we'll go on every state, and a lot of slides. It's difficult to cover all these slides, but I'll give you the idea simple, and I'll scroll down and to come at the conclusion, just to give the idea that how this model checking is working and what is the importance of this area. So representing the system in terms of mathematical object and involve this modeling usually involves the process of abstraction. So abstraction doesn't mean something is the summary, rather abstraction of any system is a kind of procedure in which you could identify few fundamental parameters. Those parameters completely define the system. So that is the abstraction. In software modeling, can also be consequence of software diversity. There's a lot of diversity of software. That's why this model checking is basically used in many languages, packages, and applying formal methods in this model checking kind of business. So in order to model a system, we need to have a formal specification like state transition, and computation, these kind of things. The fundamental concern is the Kripke structure, where we look at the state, we set up the transition and set up the property, labeling at some system. So we have the system model, and in other side, we have the requirements, and then requirements are formalized, and there is a model checking. Then we could get whether this system model is working properly or not. If yes, then okay. If no, then there is a counterexample. So counterexample is basically generated that system has a failure at this stage, and try to look at again at that system. So system design, this is also a figurative representation of model checking. And we construct a model of the system, either hardware model, software model, and then we specify the properties in certain mathematical way. And mathematically, model checking means this satisfies, this model satisfies this property formula file. So that is the representation of that. So counterexample is that if there is any kind of conflict in that functionality, like if I could give you a very simple example of microwave oven, or if I can give you example of this elevator, if I could give you an example of this Metrobus, if the door of elevator is open, then the functionality, the fundamental requirement that it should not move up or down. And that is a kind of counterexample. We make a model of that system, and we give it to model checker, and then it will elaborate, and it give us the counterexample that this system is having failure at this stage. So that is the importance. But the one it is lacking is the state space explosion problem, that because it goes at each and every state of the system, that's why if the system is having many states, then it would be difficult to explore the system. So that is the one bottleneck in that. There might be another bottlenecks, but that is the most concerned bottleneck in the application of this model checking kind of example. So various model checkers like SMV, SPIN, OPAL, that kind of model checker, if you first you make a mathematical model of the system, and then you convert it. SPIN, for example, it's a symbolic formula interpreter. So you convert in a formula language, and then you give it to that model checker, then it will give you the state-to-state kind of things. So looking at this diagram, if we have natural language, mathematical problems, programs and specification, they are formalized, and formalization through syntax, and making use of, if you look at the right side, calculus, provable extension, if you use the semantic, the valid expression. So the system could be, so that is the track of modeling. That is the track of the modeling. And this one is the track of automated deduction. So that is a theoretical concern. The left side, the modeling is a practical kind of concern if you have the system. And then you make use of these things in order to. So taking from formal theory to application, then we have the proof theory, we have the various calculi like CCS, calculus of communicating systems, and as CSP, communicating sequential processes, various calculi, pi calculi, we have the different calculi in process algebra. These calculi is not the, I would like to mention here, these calculi are not basically the concern of a mathematician. Rather, it is a pure concern of computer scientists, because in these calculi, you can express the system. At the end of, I'll just mention a few examples from my ARP applications. the application of model checking and application of process algebra that give you an idea that how important this area is because of its mathematical nature. So you can say implementation is the specific model checking problem is mathematically defined in this way. So system model and S is the specification. Specification is just that if you switch, for example, if you switch on state in the button, that it is the specification of the system that there should be a light on the room. And lot of systems are basically specified, and those specifications are basically mathematized, and afterward they are converted into practical language like Promila, like another language. Various logic make use of various model checkers, and then that model checker is basically used to identify the pitfalls or something like problems or counterexamples. I skipped that. For example, this very simple kind of thing, we can make use of model checker in order to identify any kind of area program, and then we have the model extraction. And this model checking is much more better as compared to ordinary way of looking at this code. We have a lot of examples, but just to give you a view that how this script key structure is basically used in order to have a mathematize a very simple code. So we have the different model checkers, the different classes of system model, and for a different classes system of properties. So looking at this formally, transition system, if that is a kind of movement, that movement is mathematically expressed in a transition system. This movement could be very easily represented. This movement could be represented in a mathematical way through this transition. So this mathematical kind of formulation is needed in order to have a model of something, and that is just a view of that. This labeling kind of property of the state, for example, at certain state, and that transitions you could have this just if certain vending machine. Very simple example is that we have the state space and we have the states, and then we could represent in this way so that a transition system could be, and this transition system could be analyzed in each and every, although this seems a very simple one, but when we trace it through the formal modeling, then it looks very complex one. So it is, although it's a simple one, then we can give it to certain model checker. There is a TOR representation in the system. Internal processes. You don't know the internal processes of your ATM machine. So some processes are hidden, that those hidden processes are represented in this theory by TOR. There is one example that this very simple kind of crypt key structure of this sequential circuit is given in this right side is the crypt key structure, and this structure is basically given in this way, so that the transition system of this actual sequential circuit, and this is converted, and when this is converted, then it could be given to a model checker. Again, just looking at this table, logic table, it is difficult to identify the problems, but it would be easy if you model it properly and give it to certain model checker. Then similar way, the crypt key structure for mutual exclusion problem. I've shown very simple kind of slides. If we expedite mathematically this kind of thing like the mutual exclusion problem, then it would be a little complex one, and it will go that where the failure could occur in case of mutual exclusion problem. So we have the application, we have the model checker. So like spin model checker is we make use of various languages like temporal language, and those languages are converted into certain kind of proper language. Like spin is a model checker, and spin is a kind of promila language, process meta language. That means spin, and first you represent a process in LTL, linear temporal logic. You represent it in linear temporal logic, and then you could have you can convert into promila language. Then if you give it to certain model checker, spin, and you get the states, various states of the system, that where is the failure of that's the importance of kind of this model checker. There is another area, like I just want to skip it because the fundamental requirement for spin model checker, like if you look at the propositional logic, if your idea is very propositional logic is basically used in databases, propositional logic and first order logic is basically used as the fundamental knowledge of artificial intelligence. Without knowing these areas, it is difficult to touch at the core of artificial intelligence. And that is the syntax of propositional logic. And if you extend this propositional logic with temporal modality, then you get the linear temporal logic, and you can represent, for example, eventually, always, next time, eventually, I will pass my PhD defense. Until I pass my defense, I'll be the graduate student, for example. You can represent by these modalities. A lot of examples are given over there. And then this would be the final syntax of this linear temporal logic here. I just want to skip. And this temporal logic is an additional of proposition. Prepositional logic, predicate logic, then there is a prepositional logic, the fundamental requirement of many areas of computer science, and the predicate logic where this existential variables and universal quantifier are needed, and then you have the temporal logic, and you can represent a system in this logic before applying the spin model checker. So that I could skip it. In all that is kind of bookish kind of things. You can skip it. And then I would like to address something about, because of the shortage of time, what is the process algebra? I mean, these are not the theoretical one, although their nature, their apparent phase is like seems to be a mathematical one, but that is because that kind of courses are not taught at undergrad level. Even at postgraduate level, many universities do not offer these courses. I used to offer these courses like process algebra for my MS and PhD students, and I also offer this model checking kind of course for my MS and PhD students, because I know that in rest of the universities in this city and other city, process algebra is not offered anywhere in this Pakistan. I know, as far as my information, because it is the modeling language of distributed system. It is not a mathematics only, it's the concurrency and coherence is modeled through this making use of process algebra. And distributed systems are mathematized. Similar way, we have the process algebra, we have various kind of process algebra, like LTL, we have, because of the shortage of time, I'm not going to expedite these things. Just to give the term about the terminologies, very simple kind of. Now look at process algebra. We have the different process algebra, like calculus of communicating systems or and CSP communicating sequential processes. These are the pure terminologies, pure areas of process algebra in order to represent the system in mathematical way. And there corresponding, again, there is a kind of model checker for process algebra as well. So simply what I want to say is that if you want to have the precise operation of any system, then you need to have a model of that in mathematical way, either making use of temporal logic or making use of this process algebra. Then you convert into a proper language, like, for example, Promela. Then you run a program, then it will give you the counterexample if there is some error. So just to give you, I want to coin these terminologies because I'm a little bit reluctant all the time to expedite, because this is my area, to expedite these terminologies, because in most of the cases, instead of going at the core level kind of study of computer science, people are more interested into the economic factor of the computer science. So that's why a lot of applications are basically, they're looking at the economic side, but I'm looking at its scientific side. So it is not directly because, but kindly, I have a lot of applications, a lot of examples of these applications. Like we have a published paper about the modeling of pacemaker, and we check it making use of temporal logic and make use of spin model checker. And we extended the one mode of pacemaker, verification of the, the pacemaker is a device in order to give current to heart of a patient. And we have PAT model checker. We converted the safety, security protocol into a process algebra, CSP, this little complex one. And CSP syntax might be like, just to give you the flavor. And then I just need to 2-3 minutes. I have this 3 minutes. Thank you very much. And that is basically converted. Those security protocols are basically mathematized in process algebra and are making use of a model checker like PAT. And we expedite that there is an intruder who can attack on the communication. We can identify through these making use of formal techniques, process algebra. Like a very simple example, this simple example is given in this way. This is the way of writing communication in that is CCS or CSP, the sequential processes. And these are not simply the mathematical representation, rather at the end of the day, we make use of these kind of equation, and we convert into certain model checker in order to judge whether certain example is working properly or not. So we have this syntax for CCS. Okay. So okay. The examples are not elaborated at the end of this session, but I have the 3-4 publication, rather more than that, by having direct application of linear temporal logic. One of the examples is like modeling of processes of pacemaker. There is another published paper where we have the optimization of robotics path planning. So again, making use of these mathematical terminologies. And recently, we have another kind of work in which this security protocol is basically mathematized through process algebra. And that process algebraic terminologies are used, like optimal robotic path planning and linear temporal logic, and then pacemaker mode verification, security protocol verification, a lot of application. And recently we were working on the reinforcement learning, formal verification, making use of these mathematical techniques. The only thing is that, but where is the application of these things? There's application on very, very big projects. Like if you search on the internet, where is the formal technique? You go through NASA. Every year they make a conference because they have the safety critical systems. So wherever the safety critical system involved, these terminologies like linear temporal logic, like process algebra are involved. Just to give you an idea for my young mind, especially, that this is an area, very serious area, where you need to expedite system very precisely. So it is not that much direct socio-economic factor, which is usually the part of computer science, where the dynamics changes the young minds that what kind of application is hotcake. Rather, this is a basic core of computer science. So that's why many things standing, database standing on this, artificial intelligence standing on this, your logic of predicate logic, and it is an extension of predicate logic. So other sciences are also basically involved. Thank you very much. Thank you very much. Okay, इसको plug out कर लो. Thank you very much. Thank you. Thank you for your patience. I know it's a complex thing, so I'm sorry for that.
Thank you so much, Professor Said, Dr. Raza Kazmi, and we're very honored to have you today with us.
Thank you, Madam. Very much. I'm really
उन्होंने शेयर कर दिया. So, ladies and gentlemen, let's proceed by calling. Okay, let's proceed by calling our next speaker. He is Dr. Rehan Akbar. So, let me give a brief introduction of him. So, he completed his PhD in Information Technology from University of Technology Petronas, Malaysia. He is assistant professor and head of department at Department of Information System, University of Tunku Abdul Rahman, Utah, Malaysia. His research interests are big data analytics, information system, cybersecurity, software engineering, social network analysis, and he has more than 17 years of experience in academics, research, and IT industry at different academic and management positions. His supervision experience is more than 15 years, and he is also editorial board member, reviewer, and conference committee member of international journals and conferences. He has received many international research project grants for his outstanding work in research and project development. So we're very honored to have Dr. Rehan Akbar. So let's see what he has to say. Please welcome Dr. Rehan Akbar.
Okay, thank you very much. Let me start my screen first. Okay, so before I start, I think I will not take a lot of time because I have another meeting next for some documentation. I have to submit some reports to the ministry for a new program. So I will cut short my presentation and we'll focus on the main points and we'll keep it simple so that I could finish it in appropriate time. Okay, so currently I am working in this area of big data and particularly on unstructured big data. That how, what are the issues in the unstructured big data and how we can improve it. So the main area, the research that we are conducting here in Malaysia, I have projects in this area. I have secured research grant on this multifaceted heterogeneous unstructured big data usability. Okay, so these are the main points that I will quickly go through. What is the unstructured big data? What are different characteristics of the big data, unstructured big data, importance of information extraction, what are the challenges we are facing, and how we can improve this process. Okay, so unstructured big data, if you see, it is on daily basis. You see, we have a lot of activities through our mobile phones. We have so many activities through on the social media, through emails, and we are producing large amounts of data. That large amount of data, if you see, is of two types. One is structured data and another one is unstructured data. So structured data is coming from customer CRM systems, sales, from Excel files, finance, and many other sources. But that structured data, the amount of this structured data is quite less. You can say optimistically, it is not more than 20% of the entire data that is produced in the whole world, while 80% of the data that we are producing is unstructured. This unstructured data is coming from our chats, from WhatsApp, from social media, Facebook, from through our emails, from our tweets, from online shoppings, e-commerce portals. All these sources, they are producing enormous amounts of unstructured data. And this is all is big data. So structured data, if you see, the formation of structured data in the database is, it is very well settled. It is very well organized. We can execute queries and we can derive information, whatever we need. But unstructured data is not like that. Unstructured data is, you can say, is very wild. Wild means it has so many different types. It has so many different formats that it is really difficult to organize that data into some repository. That data mainly includes text, images, audio, video, etc. So these are the unstructured data. All these sources. Let me close this one. Okay, so all these sources, digital streams, they are producing images, audio, video, text, animations. Similarly, geospatial data, GPS data, satellite data, radar data, weather forecast, traffic data, data coming from social media, sensor networks or sensor devices, they are producing a lot of data. So all these are producing, you see how big is this amount? It is almost 80%. So if you see, so every minute, 72 hours of videos are added to YouTube. 217 new mobile internet users are activated, are added to the mobile networks. 121,000 tweets are made every day. every minute. And 671 new websites are created daily, almost. So you can say that every day 300 millions of photos or these kind of data is uploaded on the Facebook by the users. And over 300 million Instagram users, they share 60 million photos. And this amount of data that is being produced on all these social media platforms, in YouTube, at Twitter, at Facebook, it is in the amount of zettabytes. 400 zettabytes going up to 400 petabytes going up to 175 zettabytes. And healthcare systems, they are also adding to this data. Other than this digital data that is coming from these digital streams, geospatial systems, sensor networks, social media, health systems, healthcare systems, those applications, they are producing also very complicated and very heterogeneous unstructured data. So till 2014, that unstructured data that was produced by healthcare systems was only 80%. By 2020, which is now 95%. So this amount of data, it is expected that by 2025, the world is expected to produce 175 zettabyte data, out of which 50%, 51% of the data will be stored in the data centers and 49% will be in public clouds. But the question is, are we utilizing all that data? Surprisingly, if you see, the situation in 2020 is totally opposite to that 2006. In 2006, structured data that was produced was only 64% and unstructured data was 36%. And within these 14 years, the fact is totally different. Structured data is only now 10% and unstructured data is almost 90%. And this unstructured data is mostly comprised of audio, video, and images, other than text. Audio, video, and images are the big portion of this unstructured big data. So the potential opportunities and solutions for big data are obstructed by the unstructured nature of data. This unstructured nature of data is creating problems in analyzing that data and deriving some information from that data and providing some solutions that how effectively we can utilize all that data. On daily basis, we upload our status on the Facebook. We share different pictures on the Facebook. Okay, on Twitter, we make so many tweets every day. Are we able to derive some information from that? When you buy from some e-commerce websites, on those e-commerce websites, you see the reviews. On different products, the reviews are given. Have you realized any of those reviews are fake or those views are real? This is also a very challenging area in the research, fake reviews. And this is also this area, unstructured data, that how we can identify that some of the reviews which are given on the e-commerce portals on different products, are those reviews fake or are those real? We have so many fake videos, we have so many fake images every day we see. How we can utilize all that data? How we can provide solutions? So solution is difficult. Okay, so the main characteristics of unstructured data is unstructured data mainly has no schema. It is very, very poor. It is multifaceted. Multifaceted means it has multiple formats. If you take only one video, this video has so many formats. It has AVI, it has MP3, it has MP4. How would you analyze that data? The technique that we use to analyze video of single format like MP4, we cannot apply maybe on MKV or AVI. Similar situation is for the images. Similar situation is for the animations. They have different types, different formats, and different standards. All they are diverse, coming from diverse sources. Data is coming from YouTube, Facebook, Twitter. All are different types of data, different formats. It is heterogeneous. There is no standardization, and it has different representations of the data. And it is multidimensional, high dimensionality. so many, you can say, variational data. Some data is related to time, some data is related to, let's say, salaries, some data is related to our personal life. It is very, very highly dimensional data. So this is a challenge, that how we can utilize all that data effectively. So information extraction process is used to extract structured content in the form of entities, relations, facts. Out of this unstructured data, through information extraction process, we derive meaningful information. Or you can say we convert unstructured data into structured data that is comprised of entities, relationships, facts, terms, all that, so that we could analyze that data effectively. Generally, there are two techniques used for the information extraction, rule-based techniques and learning-based techniques. So there are so many different techniques in both of these categories. Rule-based techniques are grammar-based methodologies, entity extractions, link or relationship extractions. Similarly, learning-based techniques are naive, Bayes, curves, autoslog, leap, SRV, whisk, Markov models. So many techniques are used. Rule-based techniques are not commonly used in the research by the academic researchers mainly, but mainly by like SAP, IBM, Google. They are using these techniques. So mainly in academic research, people are using these learning-based techniques. So the efficient and accurate transformation of unstructured data leads to improved performance of data analysis and IEE. So it depends, it is required that how effectively and how efficiently we can transform unstructured data into structured data so that we could improve its performance. Due to the huge volume and complexity of unstructured big data, it became a tedious task to extract useful information from different types of data. You can say mostly out of this 80% data, we are not utilizing it. We are utilizing only 20 to 30% data. 70 to 80% data is left unutilized. So that unutilization of this big data is called usability, that this big data is not usable. And this is the theme of this research that we are conducting right now here in Malaysia, that how this unstructured data can be made usable. That is the concept of usability. So unstructured big data has different challenges. Conventional approaches like generalizability, adaptability have less flexibility. So because these approaches are unable, these are inefficient. Because unstructured data has diversity, it has dimensionality, highly dimensional data. It has heterogeneity, different formats. It has different granularity levels. Heterogeneity of unstructured data is complicated. Because of these characteristics or features of unstructured big data, it is difficult for existing information extraction approaches to convert this unstructured data into structured formats and derive information. So why? Because the conventional approaches or existing approaches of information extraction are less generalized, they are less adaptable, and they are less flexible. They do not handle all types of data. So then it has some impact on this information extraction approaches. So variety of big data indicates the heterogeneity of data types, different representations, and complex semantic interpretation that brings challenges for information extraction. So these issues, I told you that if you take only one format, video data, or you take only image, it has so many different formats, and all images are prepared, they are made on different standards. So these different data types, these different representations of data, their complex semantics interpretations, all these bring challenge for the information extraction. Because one technique applied on one type of data is not applicable to other type of data. Because that data is totally different. It is prepared on different standards and different formats. So this is the main problem, that the unstructured big data, it is a huge deluge of data is available, but it is not usable. So this data usability, now from here, you can see what is a data usability concept. So data usability is the capacity of data to fulfill the requirements of user for a given purpose, area, and epoch. If the data that I have, it is not fulfilling my requirements, it is not fulfilling the requirements of a user. That user can be a company, that user can be a university, that user can be an academic researcher. If that unstructured data is not giving any benefit, or it is not fulfilling the requirements of its particular user, then it means the usability of data is very low. It has been compromised. We are unable to produce some meaningful information from that data. So this impact of unstructured data usability on information extraction is very high. So having various data sources, companies find it difficult to get useful data at a time for effective decision making. Data is coming from different sources. Some data is coming from ERP, some data is coming from CRM, some data is coming from Excel sheets, some data is coming from so many different tools, social media. And through dashboards or through different tools, you are able to combine all that data. But how you can derive information from that data, that is very difficult. There is no single tool that can analyze all different types of data. You can analyze video, you can analyze image, you can analyze text, you can analyze tweets. This is not possible. So data acquisition, like preparation of data, its cleansing, it is very important for the information extraction. In terms of data acquisition, the data granularity, 31%, data completeness, 47%, and data available on timely basis, 36%. It has you can say that relevant or important for data acquisition process. Okay, you can say if only 1% data is usable, but without 99% data which is not usable, you cannot get that 1% data. To get that 1% data, you need all that 100% data. From that 100% data, then you can derive only 1% data that is useful for you. So this is the impact, that if data is not usable, your whole data is lost. So unstructured data has dimensionality, it has sparsity, it has diversity, heterogeneity, scarcity, and ambiguities. These are the issues due to which unstructured data is difficult to analyze and difficult to convert to structured formats. Because of this unstructured data issues, usability issues, and these challenges that unstructured data we have, it is difficult for the users to derive different perspectives or context from the data according to their requirements. They are unable to resolve ambiguities which are available in the data. Semantic understanding is poor. Because of these challenges, we cannot derive semantics or meanings from the data. And in what context that data is produced, and in what context that data would be used, and what is the user's perspective to use that data, that is totally we cannot handle. We cannot achieve these targets. So there are solutions that that we have for some recommendations in this regard, that how we can make all that data usable through pragmatics. Pragmatics mean, first of all, we must need to know that in what context or in what perspective user is going to use that data. This is very important. I want to use this image for some of my decision making, but you have to use this image for some different purpose. Third user has to use this image for another purpose. How the same image can be used for 3 different contexts, for 3 different perspectives. This is really hard and this is really challenging, how we can solve that issue in terms of pragmatics. So that was this is the qualitative part, and first of all we must need to know this one, that how we understand the context of use and perspective of use of the data. And the second is the efficient data preparation, how we can prepare data efficiently so that all these ambiguities, dimensionalities, heterogeneity is removed and addressed. And after this, what advanced IE techniques we can apply? Is there any technique available, or we need to improve IE techniques that can handle the sparsity, scarcity, heterogeneity, and diversity of unstructured big data? And then we find some consolidated solutions who can handle different types of data. Okay, so in these recommendations, in terms of these pragmatics, we have to extract contextually relevant information. That what type of relevant information and what is the context that we need to identify. That one I have already just told you. And we need to understand the semantics of the data for its understanding. And then we need to define the needs of the users. And similarly for efficient data preparations, that how we can follow standardized approaches for preparing the data that can overcome the heterogeneity issues. Data cleaning processes, quality improvement techniques, all this we need to apply to improve the quality of data and prepare it at the level of data acquisition so that we could process that data through advanced IE techniques. And then we need to derive some consolidated solutions. So in this regard, we have already, in our research, we have already identified, you can say, three components. We have identified usability dimensions in our project. Those usability dimensions have two further components, which are unstructured data usability issues and key processes. Unstructured data usability issues in terms of availability of data, relevance of data, and completeness. And key processes, extraction, transformation, and representation of data. So we combine these two components into our usability dimension. And our next component that we are developing is a usability determinant component. That component determines the context of data use, structure of the data, and semantics of the data. Based on this usability dimensions and based on usability determinants, we define our usability rules. And on those rules, then we see how we can improve unstructured data and how we can convert unstructured data to structured data. I'm sorry, these components that I have just told you, I cannot share it with you because this is the work that we still have to publish. So that's why I cannot disclose before publishing that work. So if you want to discuss these things with me, so you can personally contact me so I can discuss with you all these things in detail. All right. So this framework that we have developed, we are now validating that framework. So, and we will publish it later. So these are from this discussion, if you see, the main challenge of unstructured big data is the usability. That this dimensionality, sparsity, diversity, these issues in the unstructured big data, they are the big obstacles in utilizing or efficient use of unstructured data. And this is the critical challenge in big data. You have tools, so many tools that you can apply. You have machine learning approaches, you have supervised learning, you have unsupervised learnings, many clustering techniques we can apply on the data. That we apply on the data that is already in the structured form, that is already prepared. I am talking about the data which is not prepared. The data, 80%, 70% of the data that is being lost, and we are not using that data. Images, video, how many videos we see on YouTube, how many videos we see on Facebook. Are we using that? No. So we are addressing that problem. Okay. So, and we are developing this framework that how the usability of unstructured big data can be enhanced in terms of its use, in terms of its context, and in terms of its structure, so that unstructured data becomes more usable, and then we can use it applying different techniques. Okay, so this work is still in progress, If you need more details, we can discuss in our private messages. Here, I told you I cannot discuss all the components of the framework because it is still uh, at the validation stage. So before publishing, university does not allow to publish this work to make it public. But I have just given you some basic idea that what we are doing, what is data usability, and what are the challenges, and how we can improve these things. Okay, so thank you very much. I have to cut short because I have some more people working out, waiting for me for the meeting. I have another meeting, so thank you very much. If you have any questions, so you can feel free to ask, or you can send me email or through message, so I will reply. So thank you very much.
Thank you so much, sir. We're very honored to have you here today with us. Ladies and gentlemen, I would like to call our next speaker. He is Dr. Salman Qadri from Islamia University of Howard. So, Dr. Salman Qadri completed his PhD from Islamia University of Howard. He is now assistant professor at computer science and IT department at Islamia University of Howard. His PhD thesis title was The Classification of Multispectral and Statistical Texture Data Using Data Mining Techniques. He's an author of many great research articles for various index category journals, and his research interests are data mining and data warehousing, machine learning, image processing, and remote sensing, along with software engineering, databases, and e-learning. His supervision experience is more than 8 years, and he supervised many great projects and theses. Moreover, he is an author of many great index and impact factor articles at well-reputed journals. So, ladies and gentlemen, please welcome Dr. Salman Qadri.
Assalamu alaikum. Today I am discussing my topic regarding this research area of this national conference in Pakistan, Lahore Garrison University. My topic is the ATCM score framework for the classification of COVID-19 from fundus images. So let's start. So now here's some introduction, contents of this topic, literature, survey, problem, statement, motivation, objective, proposed, methods, experimentation, results, conclusion, and references. Let's start our introduction. Basically, COVID-19, eye infection due to COVID-19. My topic basically related to this. The 2019 novel coronavirus disease, which is called the COVID-19, caused by severe acute respiratory syndrome, coronavirus 2, SARS-CoV-2 has spread globally. While the roots of this transmission of this virus are still controversial, we have collected confirmed 50 COVID-19 patients of eye data, which is called the fundus images data samples of both eyes. Therefore, SARS-CoV-2 may exist in the normal ocular surface of the COVID-19 patient, suggesting that this virus might be spread through conjunctival contact. We have applied different image processing and machine learning approaches on eye retinal fundus images to identify the COVID-19 patients. At an early stage, we have acquired overall a a classification accuracy which is variation from 68% to 73%, because mostly COVID-19 main route of transmission is by respiratory droplets and direct contact, but this virus was detected in the ocular surface of COVID-19 also, observed in different ophthalmologists, and it was observed that 5% of COVID-19 also exist on eyes, and also inflammation of eyes, and which is also the one of the symptoms of the COVID-19. However, it is still unknown whether the virus can be detected on the ocular surface. So, which may occur precautions, practices, eye protections in the form of goggles or face shield is necessary for healthcare professional, and which basically transmission occurs during the contact with small droplets. Research muscular surface, namely the mouth, nose, or eyes. Small droplets of the uh, droplets are spread in environment every time in the form of sneeze, cough, talks. Common symptoms include fever, cough, reddish eye, and shortness of the breath. These are the basic uh, symptoms which are being present in the patients of the COVID-19. Now, the disease is progressive. At first, it basically shows the vessels, redness, start inflammation, and eventually cause reddish eyes and irritated inside the eye. There are 4 stages of the COVID-19, mainly affect the central part of the retina, which cause the redness, irritation, and more tears in the eyes. So these COVID-19 stages, especially fundus images, we have shown here in image some diagram. Normal retina, which show at the top, then seasonal viral infection, and the bacterial viral infection due to climate changes, and then the most important area which we have to discuss, the initial COVID-19 stage and the severe COVID-19 infection stage. At the end, we have discussed. Now, these are the stages of the fundus images. Normal at the left side, initial stage, and the mild stage is also some showing some inflammation, and the moderate and the third stage, and the non-proliferative and the proliferative last stage, which is severe stage. So, why the COVID-19 occur in the different stages, and those patients who have basically fell a victim of this COVID-19 disease, these are experiences. They have high blood pressure, high cholesterol, they regularly smoke or drinking, and the patients who have diabetic, they are mostly affected of the COVID-19. Now, these are the literature survey. I have summary of literature surveys. This is different researchers showing PIRAS, it shows the different methodology, relevant matrix, and the shows RF means retinal fundus images, showing accuracy 70% almost. Then with his colleague also showing histogram features and showing the retinal fundus images 67%. Corona and these texture features showing with the implementation of ANN, artificial neural network, 72%, more than 72%, and Berberal with his research fellows showing fuse feature with deep learning, showing 73, almost less than some 74%, 73.8%, and others showing these are all showing almost 66% to maximum almost less than 74% accuracy of classification to identify the initial stage of the COVID-19. What is the problem? I have discussed earlier the different researchers use different methods for the identification of the COVID-19 stage, but fail to build standardized model. Being a complex disease, it is important to have a robust system in place. We did try our best to introduce an intelligent standardized system which can be able to detect the COVID-19 stage as an early stage, because it is very necessary to identify the COVID-19 at an early stage so that we can prevent our whole environment, our system, when it would actually in middle or higher stage, then it's very difficult to stop or to reduce the effects of this disease. So, what are the research motivations? COVID-19 is now this burning issue in the world, which destroys the whole world in every aspect of life, health, economy, communication, system, environment, and it before treatment, it's early and correct diagnosis procedure is very important. And so we try to develop an intelligent framework with the help of texture analysis using image processing and machine learning. This is the hybrid mode of the image processing and machine learning approach to early diagnose the COVID-19. Objectives, what are our objectives? The basic objectives are to develop and explore machine learning techniques for classification on the basis of statistical texture data analysis, reduce the classification error in classification for large data sets for statistical texture feature data set, to develop an efficient optimized feature data sets for each technique, to identify suitable classifier for each efficient classification. Finally, to develop an efficient automated classification system which consists of different image processing techniques. This is our proposed methodology diagram. First at the left side, retinal fundus images, and then after this, take pre-processing, because pre-processing step is very important to cleansing the data, to normalize or standardize the data, applying different filters like Sobel, Laplacian image processing to reduce the outliers or to reduce the noise, and then segmented the area which is more affected in the eye, and then extracted the most important texture feature extraction, because in this research study, we have observed different features, but texture features play a vital role because texture features are basically tonal properties, or these are the patterns which basically occur at the surface of any object, and which shows apparently the disturbance of any pattern or any surface layer. So texture features are very important in this research study. So beside this, we have also acquired different features which are run length matrix features, GLCM, wavelet features, the run length features, and then we also acquire different optimized techniques, so that these optimized techniques, all the features are not very important. Some features are important, some are less important, which cause different bulky of data, which is also important. How we can huge data sets or big data sets to process, it takes a lot of time, it takes a lot of resources, it takes a lot of also complexity issues. So to reduce all these obstacles or these issues, we have acquired the optimal features data sets, and then these optimized feature data sets are then applied to different machine learning classification algorithm, and then we did a comparative analysis of different machine learning algorithms which are being implemented for this study. Now, next, I have discussed with some detail COVID-19 first fundus image data sets. We have acquired then image pre-processing steps, then clustering-based automated region growing segmentation technique is applied on this area to extract the region of interest which are being disturbed directly by COVID disease. So extract texture feature, histogram feature, occurrence features, run length matrix feature, and wavelet features. All these features are extracted on the fundus image, and then these features have been combined together to make a fused multi-feature data sets. And then after getting the fused multi-feature data sets, we applied features optimization technique feature, which are the also a joint venture of the feature plus probability of error plus mutual information feature selection techniques, and we have acquired optimal feature datasets, which are 30 pre-optimized texture feature dataset. The post-optimized, we have also applied the correlation-based feature selection techniques and applied pre-optimized texture feature datasets. First, we get 13 optimized feature datasets, then we get after feature probability of error plus mutual information, then we also applied another feature reduction techniques, or feature optimal techniques, which is called the correlation-based feature selection techniques, and then we all acquired further reduced 13 feature datasets to only 32 further 13 post-optimized texture feature dataset, and then applied different machine learning machine learning classifiers on these feature dataset, fused multi-feature dataset. These are the basically some feature extractions. One side and other side is the machine learning classifiers, which have applied histogram feature. This is also the first order histogram feature, first order statistical feature, and then wavelet features. Also the progress matrix GLCM. This is also the higher order and run length matrix feature. These are all on different texture features techniques. Basically, we have extracted, and on the other side, when we have extracted these all these features, then we have combined, fused all these features, and then applied different optimal feature, PCA, LDA, NDA, feature, probability error, and mutual information. We have observed it is basically supervised feature selection techniques, extraction data sets. So we applied supervised feature optimization techniques, which is the feature probability of error plus average correlation. And then we extracted 30 optimal feature data sets. And then after that, pre-optimized another technique, correlation-based feature selection techniques with a greedy algorithm applied. And then we get 13 optimized feature data sets. And then these data sets is deployed to different machine learning classifiers, which are the SMO, sequential minimal optimization techniques, logistic tree, multi-layer perceptron, and simple logistic. We have applied different comparatively these 5 machine learning classifiers, and then apply different extracted different results. So for experimentation explanation, I would discuss because COVID-19 affects almost 3 to 5% the eyes of the patient or the victim. So we have acquired 50 patient COVID-19 patient data sets, and these are acquired in proper VVH Bahawal Victoria Hospital, Bahawalpur, which is COVID centers, and it is restricted now because it is the experimental results are in process, and so also the research is not till now published, and it is in premature stage. So we have at a template at a prototype, we get only we are able to get only 15 patient data sets for experimental stage to identify, and then 5 stages of the COVID-19 fundus images data set. And then because it was the 5 types of the data set, 50 for each, so 250 images data sets we have acquired, and on each image of the RF and retinal images, we have deployed 3 ROI region of interest selected. So the size of extracted data sets now enhanced to 750, because on each image we have extracted, we have taken 3 ROI, so it will enhance the data set to 250 to 750, and then applying different processing steps and different optimization algorithms, and fuse the data, and then we have be able to get 13 post-optimized feature, and then applied 10-fold cross-validation techniques. And these are the feature selection approaches which we applied, and then we get how many features. First, run length matrix on the right side, and then the 45-degree run length normalized uniformity, 45, 35, horizontal, vertical, and same progress matrix, entropy, contrast. These are the wavelet features, wavelet, horizontal length, histogram, variance, skewness, or percentiles. All these features have been extracted with the help of the fusion of the 3 optimized feature selection techniques, Fisher correlation-based feature selection, mutual information, and POE probability error plus average correlations. And these features are further deployed to different machine learning classifiers, MLP, which is multi-layer perform, SLG, simple logistic, model tree, logistic, and SMO. So then we have been able to acquire some overall accuracy. Almost MLP shows 73% time to build this model is 0.78 second, and also other root mean square error, mean average, the false positive, true positive, kappa status. These are the matrices which we have acquired during this experimental results. And overall, it was observed that these results were, although not showing so high classification accuracy, but it is also showing that in future, inshallah, we would be able to produce or to get a better accuracy result. Now it's showing almost accuracy or other parameters matrices, which is shown in table, which is 68 or 68 to 74 almost percent accuracy of these. But when we also applied on different deep learning algorithm, it is in process, then hopefully we will be able to get better results as compared to these. But this is also very helpful because our research paper is in process, and it is in first we also get the positive response in JCR. So this is research is in basically in process. So we can say in future we will be able to produce a better result and better data. So conclusively, this research was concluded that more accurate and precise results which can be achieved 68.6% to 73% by applying different machine learning, which we discussed earlier that SLG, LMT, long multi-layer perspective, logistic, and SMO. These are algorithms with the help of fusion data set, which is the combinations of histogram, wavelet, covariance, and length metric. The proposed model actually shown very promising result at this stage. Because I would say the promising is this sense because it is an early stage for identification of the early stage of the COVID-19 through eyes. So because other procedural step, which is also in biomedical sciences, is in also progress. Besides this, we also detecting COVID-19 through eyes. So in future, we will enhance the data sets of COVID-19 also, and in the COVID-19 data sets, and verify the result on large scale data set with the help of deep learning algorithms. So thank you. These are the references, and if you have any question, you can ask me, then I would be able, you can email me, I would inshallah reply you on also respond. Thank you very much, all of you.
Thank you so much, sir. It's really a pleasure having you today with us. Thank you so much.
Thank you very much.
Okay. So let me just invite our next speaker. So he is Dr. Amjad Hussain Zahir from UMD Lahore. So Dr. Amjad Hussain Zahir is currently working as an assistant professor at UMD Lahore. He received his PhD in computer science and information technology from University of Engineering and Technology. He has been an active member of Higher Education Commission National Curriculum, and he has also more than 23 years of qualitative experience in teaching. And he is rigorous in academic research, and his research interests include information security, programming languages, algorithm design, enterprise architecture, technology management, IT infrastructure, blockchain. He is serving as an effective and efficient reviewer in several reputed and international research journals of high impact factor in the domain of information security. So, ladies and gentlemen, please welcome our speaker, Dr. Amjad Hussain. Over to you, sir.
Thank you, Umar. Assalamu alaikum, everybody. Bismillahirrahmanirrahim. I'm really honored and thankful to the Garrison University management for inviting me. Worthy audience, very esteemed professors and professionals from the IT industry. Thank you for sparing some of your precious time and gracing my talk. Information security has been the subject of much debate in the recent times. The reason being, there is a lot of data and theft has been there, and misusage of this data is all around there. And the topic of my presentation today is exactly related to the information security. One of the core components that is being used for providing the information security is substitution box. So I will go for that substitution box introduction, how to create it, and what is the role of that substitution box in information security is. If we look at the total data today in the world, in 2020, that is near about 59 zettabytes. That is huge one. And look at the year 2025. This data is going to be 175 zettabyte, lot of data. Some of you might be of my same age. In 2000, we were considering ourselves lucky enough that if we had the system having 40 GB of data storage in our computer, we thought at that time, that is wonderful, wow, it is a lot of storage. But the days are gone when we were thinking about the gigabytes. A lot of data is being generated, processed, and being stored somewhere. The first question that comes into mind is really that data being generated so that we will be able to reach this 175 expected number of zettabytes? Yes. Whenever you interact with your mobile or your computer, it is being generated. Whenever you walk down your street and have your mobile with you, GPS sensors are having the data that is being created. Whenever you interact with your social media, Facebook and so on, Twitter and LinkedIn and so on, data is being created. Whenever you move in your car that is connected to the internet, you are creating your data. So these types of interactions with the systems and mobile and other devices are creating so much data. We have cloud computing, Internet of Things, big data, telecom sector, social media. Each and every factor is generating data. So it is expected that we will have this type of data, this amount of data in 2020. And even we can predict more data due to the situations like in these days, COVID-19 and so on. More data can be there. So out of this 175 zettabyte of data, storage industry will have share of 42 zettabyte expected. IoT devices will have lot of data, near about 100 zettabyte. 90%, 50% of data will be stored in the cloud environment, and real-time applications will have near about 30% of data. If we look at the growth of the data, we are here in 2020. It is near about 59, and in years 2024, 2025, it will be huge amount of data. We are creating 2.5 quintillion bytes of data per day. That is huge data. 90% of the world data, today's data, has been generated in the last 2 years. 3.7 million women interact with the internet, use internet. 40,000 searches per second are done on the internet, and the share of the Google is 77%. And similarly, 5 million searches per day are there. We look at the data that is being generated or used or processed per minute. Snapchat, so many photos, LinkedIn, YouTube, Twitter, 456,000 tweets are being made by the Twitter. Professionals or the academicians are the people who are the users of this. Instagram, 50,000 photos. Facebook, the only social media we can say that is being used mostly by the people. 1.5 million people daily. Only in the Europe, 370 million people are there. So much photos are being shared, whether it is simple photo or it is a video of your marriage, or it is the communication, that is the textual communication that happens daily, 300 million photos and so on, comments. Then we look at the messages, 16 billion text messages, emails, and so on, spam emails. So much data is being generated and stored and then processed. Some of the data will be, and definitely will be, very sensitive. It might be your own image, picture, video, or it can be the data of banks, or it can be data related to the persons of a country, or it can be the data related to anybody. But the nature of the data is very sensitive. People around the globe do not have always good intentions. Some of the users will have bad intentions, malafide intentions will be there. They can get this data, they can retrieve this data, snatch this data. So after snatching this data or getting this data, it might be used for harmful activities. It can even destroy your life. But unfortunately, we being so much emotional, we try to upload our images and videos just to have a note of thanks or note of appreciation from our friends, but we do not know what can be the effect of this uploading of images and videos. You know better than me what is happening. There are so many examples. Lives of the people have been destroyed. So data, whether it is a simple SMS or it is the data of a global organization working around the globe, working in many subcontinents or countries, they will have to communicate their data, transmit their data over the medium that is generally insecure and shared medium. So users which have the bad intentions, we call them attackers, they can use this data for some very evil activities. So there must be some mechanism, way, so that if the attacker is able to get that data, he must not be able to use that data for some evil activities. For that purpose, we will have to convert this data into some, if in such a form that is not useful for this attacker. For that purpose, what we do is, before sending the data on the medium, we convert our data into a form that is not useful for the attacker. We change its meaning. We make this data meaningless. For that purpose, what we do is, we mechanisms, procedures, or in computer science, we say algorithms, which convert our meaningful data into meaningless data. To convert that meaningful data from our side to meaningless data, we will have to develop an algorithm, use an algorithm. And that is one component that is needed for this data security. And in that algorithm, along with it, we need generally a password or key that will be not shared with anybody in the world. Just it will be shared with the receiver, who is actually the attended receiver of this data. So for that algorithm, we will have to use some mathematics or some type of things that will convert this data to meaningless data. This algorithm can operate on our data in different ways. It can pick one byte of our data and convert it into another byte, or it can pick a block of data consisting of many bytes to convert it into many other bytes. So there are different algorithms which are generally called ciphers, which operate on the bytes, which operate on the block of data. And similarly, there are different types, symmetric and asymmetric ciphers. You can read, go through the net and see what these terms are. Looking or feeling the need of the data security, even the OSI model has embedded the encryption at each and every layer, except the physical layer. Because whenever your data is leaked or somehow it is there in the hands of other people, you will reach to the courts, or you will go for some actions against the providers of the data. So as OSI model has encryption at each and every layer except the physical layer, and data encryption is in the presentation layer. So whenever we develop the algorithms, there are so many operations to protect the data. One of the major operations that is being employed in today's algorithms is substitution. And for that purpose, what we do is we develop a table which helps in substitution process. And that table is called substitution table, or more famously, substitution box. So our data will pass through this substitution box, and it will be converted to some meaningless data. For simplicity, I will say if my data consists of these three letters ABC, what I will do is I will change this with some other byte or character. So B will be converted to another byte and C will be with other character. So I will have to develop a mechanism so that I am able to convert or change my data into some other data. Different minds are there, different algorithms will be there, and another person can convert this A to X, and another person can change this A to Z. So different algorithms, different outputs are there. So this is the hot area, information security, and it is gaining much of the popularity, and 99% work in information security is on this substitution table or substitution box. So what is the magic? What is the logic? What is the difficulty in creating this substitution box? That is the question. In my words, I say it is very easy. Unfortunately, the academia and the researchers make horrified story and tell the horror stories to the student that it is very difficult. My perception, my claim is it is very easy. I will show you. So for a very simple example, let's have one of the first substitution table. Look at this one. This is my original data 0, 1, 2, 3. For example, what I do is I will change. If my data is 0, I will change it to 6. If my data is 1, and let's assume it is 1. If my data is 2, it will be converted to 8. So whatever is the data that has been changed. Now look at the input. That is my data. It is ranging from 0 to 8. It will require 3 bits or 4 bits, sorry, 4 bits. So if my data is from 0 to 7, it will require 3 bits. So for simplicity, I have gone to this 0 to 8. And these bytes are being converted, these bits are being converted to other bits. 7 will be converted to. I will convert it into a matrix, 3 by 3 matrix. So whenever there is 0, it will be converted to 6. I have to develop an algorithm, a formula, a function, a mapping, a simple equation that will change my data into this one. 0 will be converted to 6, 1 will be converted to 1, 2 will be converted to 8. And that is very easy. Simple mathematical operations are needed. Another example that is there, I have the data from 0 to 50 and these are being converted. So I need a formula that takes some input variable and then produce an other output. So that formula might be a case of seconds or it take years. It requires some passion. Look at this table. It has only 16 boxes. Can you imagine how many combinations are there? Here, 16 values can be there out of 0 to 15. One of the value will be here and rest here 15 possibilities are there. One is there, remaining of the values, one of them will be there. So total 16 factorial possibilities are there and you have to choose one of them to convert your data into meaningless data. Look at the figure and 2 days. What is happening? This the size of this table is 4 by 4. Today in cryptography or information security, we are using 8 by 8 S boxes and they have 16 by 16 dimensions, 16 rows and 16 columns. Look at the number of possibilities. How many possibilities can be there? 256 factorial. So many S boxes will be there and you will have to use one. And it will be very difficult for the attacker to get one of the S boxes out of so much possibilities. 256 factorial possibilities. Very difficult. It might be a chance of luck. 0.00000 trillions of zeros that he is able to extract or generate a box like exactly like this one. Easy one, but difficult to generate if you have the knowledge of mathematics and so on. So what actually we can say, the topic of my presentation is constructed today. I will show you. This is one of the function. X is input and Y is the output. Look at the values 1, 2, 3, 4. What will be the case? Y is being there 3. For 2 it is 4. Look at the outputs 3, 4, 5, 6. It is making a sequence. While generating the substitution box, we try to break this sequence. There must be some randomness in the output. Look at the this one. Against 1 we have 3, against 2 we have 7, against 3 we have 7. There is some randomness, and the more randomness you generate, the more secure your data will be. That is meaningless. So first requirement for generating this substitution box is nonlinear mapping. It must not be like this one. There must not be a sequence. And the second requirement is these dynamic S boxes must be dynamic. What do you mean by dynamic? We change or we have some parameters in the formula. If we change the values, different outputs should be there. One of the popular cipher of algorithm has been there, DES, data encryption set, that was using static. Its S boxes were fixed, but today dynamic S boxes are being generated. So these are the properties we go for to evaluate the S boxes, whether the S box is strong or not. This is very weak S box. This is stronger than this one. So we try to generate an S box like this one. These are the properties which we see are used to evaluate the S box. This is an example of a weak S box. Look at this one. What is the first value? 25. If x is 0. So there is a sequence. And that is not the requirement of the S box. It must be some randomly generated values. And this is one of the S box method I used in my first paper. I used this equation, cubicle, AI cube plus B. And then generally we use one of the division method, that is the remainder, that is being used in information security usually to generate these S boxes. The remainder, division process, not the quotient. So with the help of a remainder, we generally get the values, and these values are just like this one, 25, 26, and so on. So you will have to develop a formula like this one. It is very simple. Even after this one, this was my first publication. I went to the quadratic. I did not publish it. I'm just going to publish it. And then I thought there must be a linear equation. I have developed that S box, and it has been published on August 12 this year. Very simple and efficient. AI plus B, simple. So opportunities are there. Come up with a strong passion that we can generate this one. I try to help the students if they want to go for this one. Many students are having a research with me in this area, and they are able to generate this one. We're generally going to publish very soon. A strong S box, or with the help of this 120, there 250, and then different values are there. And this is the behavior of the values which are being generated. It is showing the randomness. Look at the first value, second value, and so on, the randomness. It is the primary requirement of generating this. So with the help of this equation, we can have so many S boxes, because value of A and value of B, these are the bytes. A can have 256 values, B can have 256 values. So we can have different combinations of A and B. And I did not go for 256 values because we generally do not use A as 0. So 0 is excluded. And similarly, in case of B, we do not use 0 because 0 will not have any effect of this one, this addition. So rest of the values, these make 65,000 possible S boxes, and we will use one of these one. But this is, and these are just two parameters, A and B, and this value will be ranging from 0 to 50. If you use more parameters, more values or more number of S boxes can be generated. And today, generally people use more parameters because it is all about the security of data. If your data is not secure, you will sue your code, a bank, your telecom sector, mobile companies, and so on. So they charge you hiddenly or whatever it is. And these are the tables we generally use. These are a few of the ciphers which have used S boxes, static. Then we have dynamic. AES even, Advanced Encryption Center, is using static. But the recent approach is to use dynamic S boxes because it is all about the security of your data. These are the values, these are the parameters which are used to evaluate whether the S box is strong or not. It is a bit of mathematics. We can guide you if you are having the passion. Another one is this one, bit independence criteria. If we input bit is changed from 0 to 1, due to the change of this bit, there will be change on the output bits. So two different output bits are changed independently. That is judged by this criteria. And similarly, we have another one, a single bit change in your key or in your text or in your data If that is changed from A to B, for example, it will change your data on the outer side, output side. 50% of the bits must change. If your S boxes are designed in such a way that 50% of the output bits are changed, then it will be considered a strong one. So a lot of opportunities are there. You have to be there, come and see and put your effort in this direction. Even we are generating S boxes, 6 or 5 S boxes methodologies per day. In August, I have generated more than 30 S boxes. Very easy, believe me. So thank you very much for your patience and your support from the EU management. If there is any question, I am there. Otherwise, it's okay from my side. Thank you very much. Umar, is there any question?
No, I guess there's no question, sir. First of all, thank you for giving us your precious time. We're very honored to have you today with us, sir. So, without wasting any further time, let's call our next speaker. He is Professor Dr. Abdul Sattar Sand from Sindh. So, Professor Dr. Abdul Sattar Sand obtained his PhD degree in wireless communication systems from Electrical and Electronic Engineering Department from University of Technology Petronas, Malaysia. He is now professor at Electrical Engineering Department at Qaeda University of Engineering, Science and Technology, Nawab Shah. Dr. Sand has more than 16 years of professional and academic experience of national and international level. Dr. Sand is the author of the chapter titled Beamforming for Relay Assisted NEMO. He is the author of 34 research publications published in local and international journals. At present, he is supervising PhD students. So let's see what Dr. Sand has to say. First of all, thank you for joining us and giving us your precious time, sir. So over to you, sir.
Thank you, Mr. Omar Aftab, for inviting me for the little speech about the conference, that is the fourth national conference on the computer science and information technology, organized by Lahore Graduate University. I am thankful to the management who invited me for the keynote speech in this very important and conference that will help the, I think, audience, our students and other researchers to get idea how to grow in the research and uh, research for academic purpose as well for the professional purpose. So we have always so thank you again. I am already introduced by Omar that I am Dr. Abdul Sattar. I got my PhD from University of Technology Petronas in 2016 and joined Qaeda University of Engineering, Science and Technology, Nawab Shah. Basically, I'm telecom professional, but I joined the academic in 2009. So having a great experience with Pakistan telecommunication in various sections and technical means sites. Then I decided to join the academic and contribute over here. So Alhamdulillah, I got my PhD in again communication systems and networks like this. And my area was about the MIMO. And because why MIMO, why I selected MIMO? Because already we are using the one carrier, single carrier. And everybody, whatever people are working in the area, like computer system, software engineering, or wireless communication system, all are interrelated to each other. And all are, we are just digging for the massive data, high capacity, low data. Everybody is crying nowadays. And even today, maybe somehow we are facing some problem of the low data jitters, data delay, everything. So the solution for this, when we are using the only single carrier means single traffic. So traffic can be congested, traffic may be choked, traffic may be distorted, traffic may be delayed, everything can be. Previously, as we follow or we resemble, we said that in the transportation system or road system, we have only single road. Then we have several means accident on every day. But nowadays, alhamdulillah, we have the series of motorway and we have a multi-channel traffic over there. And definitely So there's the less prone of the incident and like everything. So in the same way, the data also can be increased. Data we can store, but actually problem the transportation of the data. Why we say that there's a problem with the data? We have low data rate, means rate of the flow of the data. We have the design a very good software, we have designed a very good software. Again, but when you're talking about the transmission of the data, again, there's a problem. So we usually work on the traffic and that the transportation of that traffic, how to manage it, how to facilitate it, and efficiently, reliably that can reach to the destination or to the user. So I don't know the audience maybe belong to mostly from the computer and software engineering. That is why I have given the name that massive data and using massive antenna cooperative communication system for 5G and beyond network. So there are two objectives to let you know people, that to give you the ideal to you people. One thing is that we want to have the great capacity, means data or throughput. We want the huge data, and we want to the means high rate of data transmission. Second is the reach, means approach, because we always get the delayed signal due to the larger distances. When we are the cell edge, suppose we are talking about the wireless system. Again, we get the low power and distance is high. The number of users are increasing. The transmitted power by the base station is definitely being shared among the several users. Definitely the reach of their signal becomes low, and we are getting very low signal. And similarly, I'm also facing the same problem in my office. I'm at the edge of the BTS, and I cannot receive the call, even though Aksa was calling to me, and the call was not successful. I tried to use the again internet or the Wi-Fi of the university and talk to her. So how to solve these problems? How when we are going, everything is going to be on the virtual basis, and preferably nowadays due to the corona, preferably, and we that due to corona we have several opportunities. That is the great opportunity we are today together due to the corona. Otherwise, this conference was supposed to be organized on the physical basis. So. Uh, how to achieve these two targets, high capacity and reach of the to the user, the problem distance, that how can be means mitigated. So by using the solution that here I have sent the massive antenna, means MIMO antenna, and cooperative communication. Cooperative means so the things you have to understand here. One thing, how to get the high capacity, high throughput, and reach, and how the cooperatively devices are means working together, and how you have to look for that problem. Here I am going to means highlight one thing, that how cooperatively, how you can create the cooperation among the various devices when they are sharing the information or data. So for you people, particularly for software engineers and computer system engineer students, it will be very beneficial for them. If they want to go for the masters or PhD, they can also look into, rather than the signal processing, they can work also on the software system, that how cooperatively devices can uh, communicate or share the data. So this will be means very important for people to catch it from my speech. So going ahead. So here, the background of this talk is that recent technology development have made advanced antenna system that is a practical option for large scale MIMO deployment in existing 4G, 5G and beyond mobile network like LTE and other. It enables state-of-the-art beamforming and MIMO techniques that are powerful tool for improving end user experience and capacity and coverage. These are the main actually two main problems. Capacity and coverage issues we have a lot in the world in when you are wirelessly using your data. As a result, it significantly enhances the network performance in both uplink and downlink. By using what? By using this MIMO technology. One thing, MIMO technology means we are providing multiple carrier, we are providing the multiple channel, we are providing sending the information data, not using only one antenna. By same data can be transmitted by using the multiple antennas, providing the multiple paths. Definitely capacity will increase. How that is going to increase, we can show the some graphs over here also. Then here, at the end user performance requirement, continue to increase the putting the high demand on radio access network, that is at the RAN network, to deliver increased coverage and capacity and end user throughput. Since the data usage is currently increasing at a much faster rate than corresponding revenue, definitely, Mobile network operators must evolve the RAN in a way that enables to reduce cost per bit while meeting new demand of end user performance. So now when you are going to deploy, when we are using to deploy the multiple antennas, here in this graph, we can say at the below, we are using only the two antennas, one transmit antenna, one receive antenna. The capacity is very low. Here with respect to the SNR and capacity in terms of the bit per second per hertz, we see when you are using the one antenna, two antenna are the transmitter, two are the receiver, then we are at the below line. When we are going to increase the number of antennas as the transmitter and receiver as well, the capacity is being increased with respect to the SNR. Again, when we have the four antennas at the transmitter and the receiver here, at the receiver and the transmitter, then capacity increasing. In this way, we can validate or say that when we are increasing the number of antennas at the transmitter and receiver, then the capacity is being increased. So solution of the increasing capacity we can achieve by deploying the antennas. Definitely, when the number of antennas will increase, definitely they will create some problem. And we are here to solve that problem. Target was to achieve the capacity. Yes, we can achieve. But when the traffic increases, definitely we have to manage that speed, traffic on the channel. So here, if we are increasing number of antennas, definitely there can be interference. Definitely the interference effect will be increased. Correlation in interference impact will be increased. Leakage interference will be increased. Then here we are here to define it. We have to resolve it. We have to solve it by applying what? By applying some signal processing technique. Somehow we can say that nowadays when we are talking about this software defined radios, we can say that we have to define that signal processing using some software. We have to work on that. We have to develop a program. We have to develop a signaling system. We have to design a beam farming. Again, we can say we can design a pre-coding by applying some software system as well and signal processing technique. That will help us to resolve the problem, to decrease the problem interference. When the number of antennas is increasing, then definitely interference will increase at the transmitter, at the receiver. We can go to solve the problem. And I did myself on resolving the interference problem, not only on MIMO, but also cooperative communication, how we can go ahead. So, but solution is that the initial solution is that for increase the capacity, we can increase the number of antennas at the transmitter and receiver. Then we can say that that is the MIMO, multiple input and multiple output system. And massive, why I said that massive data, massive cooperative communication. Massive means several number of antennas. In the world, people have set more than 200, 300 antennas on the transmitter receiver, and successfully they are working on that. When number of, again I said, when number of antennas increasing, problem increasing, and they are solving the problem. And that then we can go means the unlimited thing, mean everything on the mobile, everything on the net, we can go by doing so. So this idea or this result or this graph show that by deploying the number of by increasing number of antennas at the transmitter receiver, we can increase the capacity. So first solution. Second solution is the coverage. How we can say coverage? Because when we are using the mobile systems, we have a base station, we have a BTS, base transceiver system, then we have controller. So base station have some limited power that to be transmitted at predefined distance. Again, that transmission of power depends upon the number of users. As the number of users increases, that fixed or limited power, transmitted power by the BTS is being shared among the several users. When it is being shared, definitely the penetration will be low, coverage level will be decreased. So what will happen? The people or users that are away from that base station are getting very low signal, very low power signal. How this problem can be? Again, we get a coverage problem. Number of users increasing, limited power being shared by among the several users. So this again, there's a problem. How to decrease that one? What are the mobile companies are doing so? Or the service providers? They are increasing the number of base stations. Okay, we can do, and we are doing so in the big cities like Lahore, like Karachi, Islamabad, Pindi. You can see that within the same cell area, like cellular area, we have 1, 2, 3, 4 BTS because to increase to meet the high density population. So what happens if we are going to increase the number of base stations, transferring from the macro base station to the micro base station, again capacity cost increases, technical cost increases, maintenance increases. optical fiber deployment for interconnection, that is being again it is maintenance required. So solution, easy solution, or the ready-made solution, or the workable solution, or cheap solution, that is the cooperative communication. And that is the word is thinking about that. Word is working currently now on this solution. Instead of deploying the several base stations within a city, occupying the geographical area, disturbing the every other environment, better to have this small device that can be hanged on the corner of the building or any tower, and that can work as a small BTS using the low power, and other many also things can be incorporated. That is the cooperative. How cooperation can be achieved? And what we can achieve, what type of cooperation we can achieve, what type of diversity we can achieve. Actually, diversity, when we are increasing the number of antennas at the transmitter and receiver, we can say we can increase the diversity. Diversity means throughput at the receiver or at the transmission side. So that is simply in the MIMO. But when you are using the relays or cooperative communication, we can also can say cooperative diversity can be achieved. So two things: MIMO diversity and cooperative diversity, and reach out the signal at the user successfully, reliably. So in this way, when we are talking about the cooperative communication, that is set to the MIMO assisted relay. MIMO system, but assisted by the relay. Relay is nothing but the device. Normally, we use the relays in the power system protections like this, that they transfer the signal. Here again, the function of relay is to transmit or transfer the signal, receive signal, process it, and then transmit it. There can be several types of the relay available in for this purpose. Simply can be amplifier and forward relay, can be decode and forward relay, can be just forward relay. There are several types of relay over here. But the function of relay is to get the signal and transmit it to the another destination or next destination. At the relay, again, we can also design a system. We can also design a signal processing for the transmission reception of signal to mitigate the interference, to mitigate the other factors that affect the transmission of the information from transmitter to the receiver. So the technologies such as 3G, 4G, 5G, LTE network, and massive MIMO are promising to provide what? Again, high data rate, reliably, cost effectively, and on everywhere basis within the cell region, at the cell edge and beyond it. There are two practical approaches to tackle the problem of coverage and capacity in existing networks. One is increase the number of BTS. Okay, again I said that is the costly solution. And second solution is the deploying the relay station, small relay station, which are cost effective, that can extend the range of the current BTS and increase the capacity with the use of MIMO technology, guarantee of the quality of service, and increase the reliability of the transmission signal from transmitter means BTS to the end user. Further, the performance of the relay assisted network can be improved with what? Some signal processing techniques, these. Because when I said that when we are going to increase the number of antennas, the interference will definitely be there. The leakage interference will be there. The correlation interference will be there. The these can be only solved by using some systems. By using some system, some signaling system can be applied on those antennas for transmitting the effective signal, interference free or less interfered signals. So beam farming is nothing. It is a signal processing technique or pre-coding technique that help us to mitigate these problems of multi-user MIMO antenna system. So here, in this scenario, we have incorporated one relay over here, a device that also have multiple antennas as the receiver, and at the transmitter again. We have a source, any BTS, then in between the user and that we have a relay station, and relay station also incorporating some antenna with the receiving side and at the transmitting side. So signal transmitted by the BTS over here from the source is received by the receiving antenna of the relay, and then after applying some signal processing technique, some beamforming technique, and after reducing some interference, the signal is being forwarded to the user. So this function, this actually relay works as at the place of the as a relay station, or this can help us to reduce the deployment of new BTS stations or base stations, and it can also help us to cover the distance from the transmitter to the end user. And here are some other means mathematical models or systems that in which we can also, how we can means beam farming, beamform or signal processing apply on the. So suppose here simply we have a equation that y is equal GFSHS plus GF and R plus ND. So these are actually the output. Then we have the GF and SF, the signal processing technique. Then H is the channel, S is the signal. So this is signal processing. I'm not going inside this because it will take much time, but this is the idea that how we can work on that. So the idea, if we increase this scenario from single relay to multiple relay and multiple scenarios, we have a calculated or very quantized picture over here, big picture over here. The dual hope relay assisted network, the cooperative communication based on the relaying information from a source to the destination to improve the reliability of communication system and extend the coverage. It improve the throughput, obtain the spatial diversity, and overcome channel impairments such as fading, shadowing, and path loss. Everything can be also decreased by deploying the relaying system to attain the targeted condition of the coverage and capacity among several important challenges. One or multiple relay are deployed to assess the communicated rate between the source and destination. So here is the big scenario, big picture, that we have a base station, and scenario we can have many. Means one BTS station, one relay, and one user can be. Means single user, single relay system we can have. Second scenario, we can have the one BTS, one relay, multiple user can be. Means one BTS, one relay, and multiple user we can have. And third scenario can be single transmission system BTS, several parallel relays can transmit the same information to the user, and other one is the cascaded or serial relays. Means we can say that the relays are connected in series. So when we are talking about the multiple relays, here is the problem, that how these relays are sharing the same information transmitted by base station to the user. Now the research problem over again here for the software engineers and communication system engineers here, how these relays we can make the cooperation among these all relays, that how we can select the effect to a best relay to work at a time, and how we can synchronize the cooperation of these all relays. Again, this is the area that can be digged out by the telecom engineer, by the software engineers, IT related engineers, and electronics engineer also can work on that. That how we can look at the synchronization of these relays. So in the next, we can have a lot of means how if we go ahead. One minute, please. Hello. सर मुझे कड़ी हले पे स्पीच है बना तो 10-15 मिनट में गए थोड़ी आया मुझे पे हले की नोट स्पीच पे लेंगे महेश कुमार डॉक्टर महेश कुमार इलेक्ट्रिकल जी थैंक यू sorry. So here I am I have just giving them the idea of the new student that how they can grow in the research. When you are going to look into a matter or in an area to look for a problem to solve it a sequential order. So this flowchart will help you a lot. That related when I was working in the this area, I said it's a related MIMO. In that what can be? There can be two area: single user MIMO or multi-user MIMO MU. Then in that what relay. The relay, what type of relay strategy must be there. What type of relays can be decode and forward relay, can be amplify and forward relay, can be compress and forward relay. Then if I'm working only on the amplifier forward relay, I have to look into that. I just drop these two relays, decode and forward and compress relay. Go inside that relay, amplify and forward relay. We can have a single other different scenarios. Single relay dual hop network, single relay multi-user MIMO network, multi-relay dual hop network. Then what I'm going to do, what I'm going to solve it, I have to solve some problem. What interference, what is, how can be mitigated by applying some signal processing technique. And that technique is said to be the beam farming technique. In beam farming can be, okay, signal processing can be linear, non-linear as well. If I'm working on the linear, then I am going to look into that one. And I drop the non-linear technique. If I'm going to work in the non-linear, definitely I'm going to drop the linear and working on the linear or non-linear techniques. Then I will look for the non-linear techniques. And if it is required to compare these all, I definitely will incorporate these all both. So inside the linear beam farming, we have again several techniques people are working on that. Means the zero forcing only to mitigate the noise, match filter, and the zero forcing mitigating noise and interference altogether. If we're working on the zero forcing, regular zero forcing, we can have MMSE, minimum mean square error type that incorporate both. There's a trade-off between the noise and interference mitigation also. Then we can have any proposed technique that is much may be better than these all techniques. So here, again, if we look at the problem, when the multiple antennas are being incorporated, again, the interference is a big problem. Simple interference can be external interference, can be internal interference, can be. Internal interference, what type? Can be the interference among the antennas, among the multiple antennas. This is the big problem. Capacity can be achieved, cooperation can be achieved, coverage can be achieved, but there's a problem, that is the interference problem among these all antennas. And third problem is that if we are, how the cooperation among these antennas and the relays can be maintained, how can be achieved. This is the problem, and that is the result. When we are going to solve some problem by applying some logics, by applying some techniques, by applying some methods, rules, system, then that is the research. And somehow we are going to not, somehow it is not possible to solve the 100% problem. But at some level, you can also solve, you can contribute in a particular area. I also contributed in that section, that our proposed technique also mitigated a lot of interference in the system as compared to the systems provided by the other researchers in the world. So here, the handling interference is one of the most critical problems, followed by the delay and cooperation among the relays. The problem of interference due to leakage is a challenging problem that need to be mitigated in the relay downlink precoding. The problem of core channel interference CSI and noise at the relay receive side need to be mitigated by suitable relay receiver technique. As I said, that at the relay, we can apply the signal processing technique. At the receiver, when we are detecting the signal, we can apply the signal processing technique. When, again, we transmit the signal, again, we can apply the transmit technique that help us to control the interference. So these interference have high impact on the relay. What in the channel capacity will be increased, efficiency will be increased, and reliability of the signal to reach at the destination definitely will be increased by incorporating these scenarios or systems. So these are the particular things I'm not going to discuss. The time is very short. And so here again, there are several scenarios or systems or methods in the different way they can be applied. Here simply the things I'm going to apply. I have applied that is the match filter, signal to leakage noise ratio, maximization by using FKT, Fakunaja constant form. I'm not going to inside that one, but these techniques that help us to design the signal processing for transmission and receiving and the reception of the signal at the relay station or at the user station or user side. So one scenario can be this one. Other scenario can be means a single source, single relay, multiple user. If the system becomes complex, definitely mathematics also becomes complex, and you have to design it. You have to prove it, because without mathematics you cannot go ahead. When we are in the designing system, in the mathematics is very helpful in our area of the engineering. And without mathematics you cannot grow. Yes, okay, we are going to professionally work, but academically and research, without mathematics there's nothing. Only in the air you cannot talk about the things that the logically and professionally can be proved and tested or validated through the help of mathematics. So again, here we have the very important scenario that I wanted to show you, that for the computer and software engineer, to maintain the synchronization among these relays. This is the open area problem nowadays is still available. You can work and you can go for this. You can see that how to these relays cooperatively communicate each other, means communication between these relays and cooperatively transmission of the information from transmitter to the receiver, transmitter to the how can be maintained. This needs to be means as you are working on the routers, how the router being configured and priority being set, you have to set priorities in this. You have to consider that these are some type of the routers, and these routers are sending information to the destination. How the priorities are going to be set, how the scheduling are settled over here. You can also work in this area. One word that I told you, that beam farming over here, beam farming, nothing, the pre-coding. And that is again very much important. When you have recently listened that in the New Zealand, first power grid, wireless power grid is being deployed and commercialized. First power grid, wirelessly power being transmitted in the New Zealand. First word commercial grid is being deployed or no. What is happening there? They are actually sending the electrical power wirelessly. What they are doing beam farming. When I
Excuse me.
saw that report, I studied that report, I became very happy that the idea, whatever the idea we have, we can also take this idea and apply in the wireless power transmission as well. Because actually whatever we are doing, so here in the BTS and wireless mobile communication, actually managing the power, actually maintaining the power, and that signals carry the information as well. So, but the in electrical side, again, we can apply we can test these techniques that are already being used in the wireless communication, can be used to effectively transmit the electrical power that is already in commercial now and New Zealand as well. So there are several areas and there were mentioned several things that can help us to achieve the massive data and massive by using massive antenna and massive cooperative communication. So things are many to discuss with you, but I think time may be short. I have taken already much time, and if any question you have, you may ask to me. So there are several things. Maybe at this stage it is higher than you, but the one thing that I share with you that you can also computer system engineers or software can also work on the software defined radios that can help us to increase the capacity to meet our the data requirement and the reach of the data at the end user. Thank you. If you have any question, welcome please.
Thank you so much, sir, for sharing your prestigious work with us, and we're very honored to have you here today with us. Thank you for
Thank you.
taking your time.
Thank you.
Okay, so ladies and gentlemen, let's call our next speaker for this session. So I would like to invite Dr. Alladita. He's Assistant Professor, IT for Division of Science and Technology, University of Education, Lahore. He did his PhD in Computer Sciences from from the College of Computer Sciences, Beijing, University of Technology, China. Okay, he joined the Department of Information Sciences, Division of Science and Technology, and working as an assistant professor at the University of Education, Lahore. His research interests include information security, digital steganography, cryptography, network security. Dr. Alladita authored more than 25 research papers, including 9 published papers in the Impact Factor, leading journal in the field of computer science. So, ladies and gentlemen, I would like to please welcome Dr. Alladita. Over to you, sir.
Thank you so much, Mr. Umar. Bismillahirrahmanirrahim. First of all, I want to say the thanks to the Garrison University and the conference organizing committee to give me a chance to share some ideas with research community. Thank you so much. Here is my talk title. Today, I'm going to discuss about how you can secure and size-efficient algorithm to enhance the data hiding capacity and security of cover text by using Unicode. So I divide my talk into 3 sections. Section 1, we discuss about the motivations of research works, research objectives, research problems, significance of information security, steganography versus cryptography, and the application of information security. And then we discuss about something about the current work in which text-based steganography and technical steganography, and after that I conclude my talk. Due to the advancement in information technology, web and communication security of digital content has become an important issue for content owners and distributors. As you people, one of our speakers, Mr. Amjad Zahid, discussed about the S-box, and he discussed about his research about the S-box to apply the cryptography. My talk is about the other phase of information security, that is steganography. So we discuss about the steganography, and cryptography is one of the prospective solution to secure the contents. Already much information shared with you people, how you can secure your communication during internet, and how you can secure. There are multiple techniques, multiple algorithms to secure your communication, such as you can secure the documents by applying the cryptography, you can secure the documents by applying steganography, digital signature, and so on. But my research objective, I focus on the steganography. So how to generate the steg text for securing secret information, and how you can improve existing algorithms. For this purpose, there are multiple questions why we need to protect the data. There are very important questions due to advancement in information technology. Exchange of information is a critical issue. Sensitive data always needs security and confidentiality. Intruders and hackers are always there. So in all above scenarios, the process of sensitive information exchange must be secure and secret. So how you can apply security on your contents? You can apply security by using different information security algorithms. I divide information security into two subcategories, that is cryptography and steganography. By applying the cryptography, you can secure your contents to convert the data into the ciphertext. And when you apply the steganography, you can hide the existence of data behind the cover object. That cover object may be an image, maybe audio, maybe video, or maybe a text. So we discuss about the technical steganography. A lot of research have already done by applying the steganography by taking the cover object as an English test, where researchers apply to hide the secret information by applying text steganography, by applying null cipher. They can hide the information in each character. They apply algorithms to hide the secure information, secret information after each word. There are multiple algorithms. Another technique by shifting line and word up and down. And another technique that is published already, that is feature coding and abbreviation. You enlarge your text to hide the secure information, or you can use the abbreviation to hide the secret information behind the cover object. The main drawbacks of this proposed techniques is that if you apply OCR, optical character recognition method, then you can remove the secret information from that cover object. And if cover object contain a secret object, that converts into the steg object. This technique also applied in another language, that is Arabic language. And if you apply steganography on Arabic language, Sherali Shiraza proposed a technique to hide the secret information to change the positions of dots in Arabic language. Here you can see the image and the Arabic letter known, the actual position of dot, and after applying the steganography, the position of dot is changed. So you can say the visibility is compromised. The drawback of this technique is that the visibility is compromised, because all of you know that where is the actual position of dot on the word, on the normal language. Another technique that is proposed by the Gutub et al. He apply steganographic algorithms onto the Arabic text to hide the secret information before and after dotted letters by inserting Kashida letter into the text. Here you can see in this image the actual data. The first one, Arabic language, Man Hasanul Islam, Al-Mara Tarkan Mala Yaini, and the second, after implemented the steganographic algorithms, the composition or visibility of the text is changed. You can see the Kashida letter is inserted between meme and no. So here also it is a drawback of this proposed technique. The visibility is compromised. One another author proposed another algorithm to hide the steganography, to implement the steganography on Arabic text, to hide the secure information into cover object. They omit some diacritics from the actual cover text to hide the secure information. Here you can see the difference from 1 and 2 second image before applying the steganographic algorithm and after applying the steganographic algorithm. There's a much difference. There are some diacritics missing in the last one image. So this is also a drawback of this technique. The hidden data destroyed when retyped the text, and also have the capacity for hidden data is in dots very less. And one another, which one we discussed, that is diacritic approach. They use only one diacritic to hide the secret data. And nowadays, Arabic language used without diacritics. So they failed to hide the secret information into the diacritics, without diacritics language or text. The major drawback is to compromise on visual similarity, which attracted the attention of intruders. You can apply steganography and application of the information security. You can say everywhere, from government, from military, defense, health, business, and individuals. From everywhere, we want to secure communication. We want to secure our documents. So how you can secure your document? By applying different information techniques. And today we are going to discuss about the steganography. How you can apply steganography to secure your communication. Steganography provides you two different techniques, sub-techniques, that is linguistic steganography and technical steganography. And further it divides into some sub-techniques. Linguistic steganography divides into divides into null cipher steganography, and technical steganography divides into image, audio, video, and text steganography. And today we are going to discuss about only text-based steganography. So here is our proposed mechanism to implement text-based steganography on the Arabic text. Here you can see you select a secret message that you want to communicate from sender side to receiver side. So you convert your secret message into binary. That is the first step. You convert your secret message into binary. And then after that, on that binary, you can apply one's complement, as Professor Dr. Ramjad Zai discussed, how you can change your real bits to another shape. He's discuss about by applying the cryptography, by applying the S-box, by applying the substitution method. So we have multiple techniques how you can change your existing information to another shape. So here I apply one's complement on that binary. After that, get inverted secret bits and apply the proposed algorithm on that bits. Here I apply in the red box, apply embedding algorithm into the cover object and generate the stack text file. So this stack text file will be communicated on the communication channel. On the receiver side, apply the extracting algorithm and gets binary, that is one complement. You have to apply on that binary again reverse. We are working on receiver side. So on receiver side, we have to apply our algorithm in reverse order. So we again apply one's complement, and then the secret message receiver can receive from that text. What is the methodology? Yes.
Sorry to disturb you. Sir, kindly up thoda sa wind up karna jaldi, please. We're short on time.
Please.
Okay, thank you so much.
Here is a methodology. We have 28 Arabic letters, and between 28 Arabic letters, we fetch the 6 letters as a special letter. Here are highlighted. You can see these are highlighted letters. That is called special letter. Why we called these letters as a special letter? You notice that 28 letters can connect between the next letter and the previous letter. These 6 letters cannot be connected to the next letter or cannot be connected to the last letter. Here you can see that in this box, wow is our special letter. It is not connected by the next letter. Alif is a special letter. It is not also not connected to the previous letter or next letter. We apply this technique to embed our secret message. Here is the algorithm, how you can embed your secret bits in this cover object. This is a proposed equation, how you can calculate how much secret information you can embed into the cover object. And by applying this cover object, you can see in this words, وَمَا أَرْسَلْنَاكَ إِلَّا رَحْمَةً لِلْعَالَمِينَ, you can hide 50 number of bits into this words. So the result of our research is that if you apply the Kashida approach in the same text, you can apply, you can hide only 6 bits into that selected words. And if you apply our proposed algorithm, you can hide 58 bits into that cover object. This is our achievement in according to given algorithm, and it is published in the well innovated journal. That's all from my side. Here you can see the results of discussion. Thank you so much from my side.
Thank you so much, Jazakallah, and we're very honored that you shared your prestigious work with us.